Hello, class. So we are in section 10.4, inscribed angles and polygons. Our learning target is to use properties of inscribed angles and inscribed polygons. Our success criteria, I can find measures of inscribed angles and intercepted arcs, new word there. I can find angle measures of inscribed polygons, we have talked about those, and I can construct a square inscribed in a circle, which we will put off until later. All right. All right, so our first vocab is inscribed angles. Inscribed angles. I'm using the back of my book because I don't have my thing with me. So it is on page 97. Inscribed angle is an angle whose vertex lies on a circle and whose sides contain chords of the circle. All right, so an inscribed angle is an angle whose vertex lies on a circle and whose sides contain chords of the circle. All right, so let's just kind of rough draw a circle. Circle P. So if it's an inscribed angle, then the vertex is actually on the circle. So maybe here's our vertex right there. Let's call it V. So there's the vertex of our angle. The sides are chords, so it has to go from this point to another point. So let's just say we go from here to here. So here's point W, and we go from here to here. Here's point Y. And so because this angle right here has its vertex on the circle, and the chords are the sides of the circle, this is an inscribed angle. And so, it's generating this arc, WY, right? So to kind of get a feel about it, if I were to create an angle, a central angle, remember central angle has its vertex at the center. So if I were to go like from the center P to W and then from the center P to Y, this is a central angle. So a central angle has its vertex at the center, an inscribed angle has its vertex on the circle. But they're both generating that same arc WY, right? And we know that if we have a central angle, that the measurement of the arc is the same as the measurement of the angle itself. So let's just say that this is, say, 110 degrees. Okay? So then we know that this arc is 110 degrees as well. So the measure of arc WY equals 110 degrees. Okay? All right, so let's see what we learned about inscribed angles. Okay, our next word is intercepted arc. Same page, 97. Intercepted arc is an arc that lies between two lines comma rays, comma or segments. So an intercepted arc is an arc that lies between two lines, two rays, or two segments. Well, a chord is a segment. So since arc WY lies between chord VW and chord VY, it is an intercepted arc. So this is an intercepted arc. Okay. All right, our next vocab is subtend, S-U-B-T-E-N-D, subtend. So it is on page 103. If the endpoints of a chord or arc lie on the sides of an inscribed angle, comma, the chord or arc is said to subtend the angle. All right, so if the endpoints of a chord or arc lie on the sides of an inscribed angle, the chord or arc is said to subtend the angle. So subtend is a verb, right? So arc WY, right, subtends angle WVY. So the arc subtends an inscribed angle. It does not subtend angle WPY because angle WPY is a central angle. It's going to subtend that inscribed angle. If we were to draw chord WY, which is also the endpoints of this inscribed angle, we would also say that chord WY subtends angle WVY. All right, how are we doing? Okay. All right, we have a theorem. Theorem 10.10. The measure of an inscribed angle theorem. All right, let me find my theorems back here. I should have done this ahead of time. No, I'm sorry. They're back here somewhere. Theorems. All right, 10.10. We're on page 128. The measure of an inscribed angle is 1/2, or as a fraction, looks like this, okay, is 1/2 the measure of its intercepted arc. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. So if we come back here, angle WVY was an inscribed angle and it intercepts arc WY. So this theorem says that its measure is half of what that arc measure is. Well, the arc measure is 110 degrees. So this measure is 110 degrees divided by 2, 1/2, okay, or 55 degrees. All right, so it's important to get this visual that this arc of measure 110 degrees has a relationship with both the central angle that intercepts it and the inscribed angle that intercepts it. It is congruent or equal to the measure of the central angle, but it's twice as much as the angle measure of the inscribed angle. So the arc measure is twice as much as the measure of the inscribed angle, or the inscribed angle is half of what the intercepted arc is. However you want to look at it, really kind of depends on what you have. But hopefully you can even see this is definitely, greater than a 90-degree angle, and this one's definitely less than a 90-degree angle. So if this is 110 degrees, that can't be 110 degrees because it's smaller than a 90-degree angle. So even if just your understandings about angle measures should help you to make that distinction between what's going on in the central angle and what's going on in an inscribed angle. All right, so if you need to pause the video to put out the extra practice handouts, let's go ahead and do that and then come back on. All right, so in the 10.4, let's go to the extra practice side and let's look at numbers 1 through 8. So we are given that we have circle P and that the measure of arc LM, that's this measure right there, that is 84 degrees. We're also given that the measure from K to N is coming like this, is 116 degrees. Okay, on an exercise like this, I have some options. I could just start at number 1, number 2, number 3, number 4, and see if I'm figuring it out. And that's totally a way to get through it. Personally, what I do is I look at what's given, and then I just kind of work with a diagram, and I fill in what I know. Since this is central P, and there's no angles coming from P, we are the center of the circle. We do not have any central angles, okay? But we do have some inscribed angles. So if we look at this arc LM that we were given, it subtends this arc right here. So this inscribed angle intercepts arc LM. It's inscribed, so its measure is half of what this is. So this measure right here is 1/2 times 84 degrees, or 84 degrees divided by 2, or 42 degrees. So this would be angle MKL, or LKM, and angle MKL is right here. So we know that this measure right there is 42 degrees. Are there any other inscribed angles to generate this? Well, look at the chords. M goes here, L is here, but M also has a chord here, and L has a chord here, and so angle M and L also intercepts arc LM, and it's an inscribed angle, so this measure is also 42 degrees, half of the 84 degrees. So that's L and M. Is that over here? Yep, here's measure of angle L and M, so that is also 42 degrees. All right, if we look at the measure of KN, so KN has this chord and this chord, so that would be angle KLN. This is an inscribed angle, so it's going to be half of the 116. So this entire angle here is 1/2 of 116 degrees, or 58 degrees. So this is, whole thing is 58 degrees because it's generating that right there. So that would be angle KLN. KLN is right here. So the measurement of angle KLN is 58 degrees. To get this arc KN, though, it also goes with chord NM and chord KM. So this angle right here is also subtended by arc KN. So this angle is also a 58 degree angle, and that's NMK. NMK, so that's this one. So this one is also 58 degrees. All right, also, we know that JL is a diameter, and because it's a diameter, it becomes the hypothesis of a right triangle. So we know that angle JKL right here is a right angle. So do we have JKL? Yep, and measure angle JKL. Okay, that one is 90 degrees. Well, if JKL is 90 degrees and MKL, this one is 42 degrees, we can find this one because they have to add up to 90. So this angle is going to be 90 degrees minus 42 degrees, or 48 degrees. And that is angle JKM, right here, angle JKM. So angle JKM is 48 degrees. We're doing pretty well. We only have 2 left. All right, so we want some measurements of some arcs. So if we look at LKJ, LKJ is this arc right here. Its chord is a diameter, and so because that's a diameter, arc LKJ is a semicircle, so its measure is 180 degrees. We also want to know arc MJ. We want to know this one from here to here. Right? So MJ, we don't have any chord. Well, here, M chord goes up here to K. J also goes down to K. So arc MJ subtends angle JKM, but we just found that angle JKM is 48 degrees, and this is an inscribed angle, right? So it's half of what that arc would be. So the intercepted arc is going to be 2 times the 48 degrees, or 96 degrees. Oh, all right. So it's like a puzzle. So hopefully some of you get kind of excited about these, just kind of start. I didn't go 1 through 8. Some people do, but if you get stuck and you can't figure out what to do with number 5, go on to 6, 7, or 8 and kind of see where you're going. I personally just kind of fill in the whole thing for the most part, what I see, and then I look at what's still there and work through it. Okay. All right, so in your groups, so in class, we did extra practice. Numbers 1 through 8. And in your groups, extra practice, do numbers 12 and 14, and then flip the paper over, and on the reteach side, numbers 1 through 3. So pause the video and then come back after the groups are done. Okay. All right, welcome back. Our next section, our next topic within this same section is using inscribed polygons. Using inscribed All right, so our first vocab word is inscribed polygons. All right, inscribed polygons. Page 97. A polygon in which all the vertices lie on a circle. A polygon in which all the vertices lie on a circle. All right, so we have looked at triangles this way. So if we have a circle, circle C, if I have point A, point B, point D, and I draw chord AB, chord BD, and chord AD, I now have a triangle inscribed in the circle. So it's an inscribed triangle. If I have a circle, circle P, and I have 4 points, maybe A, B, C, D, and I draw chord AB, chord BC, chord CD, and chord AD, I also have an inscribed polygon, but this time it's a quadrilateral. So now I have a quadrilateral inscribed inside the circle. So an inscribed polygon is inside the circle, and all the vertices of that polygon lie on the circle. All right, so let's look at theorem 10.12. Inscribed right triangle theorem. Inscribed right triangle theorem. Sorry, looking for my theorems in here. Ah, there they are. I need to put another marker in here where the theorems are. Okay. All right, so theorem 10.12, it's a long one. It says if a right triangle is inscribed in a circle, then the hypotenuse is a diameter of the circle. So when it's a right triangle that is inscribed, then the hypotenuse has to be the diameter. Conversely, if one side of an inscribed triangle is a diameter of the circle, then the triangle is a right triangle, and the angle opposite the diameter is the right angle. So we've already kind of talked about that. That showed up here in this problem, that because JL was a diameter, then this was a right triangle, and we had a right angle right there, right? And, this angle right here subtends half of the circle, so this would be 180 degrees around here, right? So if we have a circle and we have a diameter, let's call this CD, here's our center P. If this is a leg of a triangle, a side of a triangle, say I put my other side over here, once I draw that triangle, because I have a side that is the diameter, this angle A must be a right angle. Number one, it's subtending a 180 degree arc, and it's an inscribed angle, so it's half of that. So it makes it 90 degrees. Kind of cool. And then conversely. Okay. And then theorem 10.13. inscribed quadrilateral theorem. Okay, the inscribed quadrilateral theorem on page 129 says a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Remember, all the angles in a quadrilateral add up to 360 degrees. So if that quadrilateral happens to be inscribed in a circle, its opposite angles have to add up to 180 degrees. They're supplementary. All right, so we drew one over here. So because we have a quadrilateral inscribed within a circle, angle A is opposite angle C. So if we took the measure of angle A and added the measure of angle C, we need 180 degrees. They're supplementary. And because angles B and D are opposite angles, then we know that the measurement of angle B added to the measurement of angle D also equals 180 degrees. Supplementary angles. All right, so if we go back to extra practice, put it in here, extra practice. In class, let's take a look at number 9. So extra practice, number 9, we have a quadrilateral inscribed in a circle, so we know that opposite angles have to be supplementary. So the measurement of angle J plus the measurement of angle L has to equal 180 degrees. So we know that 5x plus 110 equals 180. So if we subtract 110 from both sides, 5x equals 70. So if we divide both sides by 5, x is going to equal 14. Same thing about m and k, they're supplementary. And so 104 plus 2y has to equal 180. If we subtract 104, 2y will equal 76. And if we divide both sides by 2, then y equals 38. A little easier than numbers 1 through 8 were up there, right? Okay. All right, so as a group then, work on numbers 10 and 11. And then in reteach, as a group, numbers 4, 5, and 6. And then this finishes section 10.4. Today is Monday, so it is due Tuesday. And the chapter 10 mid quiz. So it opens. Opened. It opens on Tuesday, right after midnight tonight, right? Opens on Tuesday and is due at the end of Wednesday. All right. Hope this goes well for you, and hopefully I see you on Wednesday. All right. Bye-bye.